So this is the non-washed page. So this talk, if you're in the right place, is about distributed tracing. And different than some of the talks I've done before, this one is less code and more about what people are doing, like how they roll out things and where to find information about that. Its goal is to kind of connect to real life, because we live in these worlds with natives and clouds and things, and it's good to find some concrete information sometimes. Hopefully, you'll tell me if I've achieved this goal or not. I'm Adrian. I work on the Spring Cloud team at Pivotal with some colleagues who you've probably seen sessions from today and tomorrow. I'm focused on distributed tracing since at Pivotal, maybe almost 3.5 years now, but before that also when I was at Twitter, where the last project I worked on was something called Zipkin. And Zipkin is a Turkish word for harpoon, like that you throw at a whale. And they made this tracing system to find out why the fail whale would show up in the apps back then. And that was a project I didn't start, but I helped move it into more open source. Firstly, how many people here have worked with distributed tracing before? Okay, a lot of you. And how many does that mean Sleuth? Okay, yeah, some people. So I will try not to belabor too much, but I think there's probably some people who might need a very quick primer. Also, I'll try to leave some time at the end. I know there will be pressure between me and the beer, but if you want to run into beers, you can take me with you also. But firstly, for I think 4 years, which is not a long time in application performance stuff. Many people have been doing this for like 20 years, but for me, it's been 4 or something like that. Each year, I find it easier to say what tracing is, but it's always difficult. Here's the current best slide I can come up with what are the most important things to think about this versus something else. And you can read it for yourself, but the idea is firstly the tracking nature, and it's going across hosts. And like correlation, you have a tracing ID. But the most important thing is that you can achieve causal relationships, meaning that you can tell specifically what request resulted in another one independent of time. So it's not dependent on clocks being synchronized or anything. And so you can draw pretty diagrams and look at them to help you blame other people for what your problems have. And maybe there will be some things that are easier to see in a way displayed as images as opposed to like log lines. And the why do I care slide is another one that's subject to thrash over the years because people care about different things. And this will follow up with some examples from actual quotes from people. But most of the time, I think people are most interested in a triage. Meaning I want to know what's most important about this problem so I can focus my time on that. And it achieves this by contextualizing errors within the context of what call came in first, does it matter, and other things like time, like how long did it take. People also care because it can help you visualize time in service, because maybe we have SLA concerns and we want to make sure that our service is performing, but we also want to know if others are being impacted by us or we're impacting others. So the idea of visualizing the relationships between you and your services that you may be blocking or blocking on. And increasingly, this fourth bullet is probably going to promote to the top because applications are getting more complex. They're breaking into smaller pieces on ephemeral, as ephemeral as a function call now. And not just the architecture, things like Lambda or whatnot, but also just the nature of how we're coding. We're doing reactive, and that's also cool, but it's quite hard to track where things are happening. If things occur during assembly time of your functional compositions or runtime, and tracing can help you understand what actually happened, at least. So besides the individual requests, another common reason people care is that they can see their architecture. I wouldn't say that someone looks at an image of their architecture and has like this brilliant insight by looking at 5,000 things connected to each other, but there are some values in here. Mainly if you think about what are the sources of traffic in coming to your service and what are you calling out to. Even if it's only one level deep, this is important. There's more details about this I'll get to. But I think this is sort of like an intro of why a lot of people care. Besides, you can probably get stickers with distributed tracing. I think I have one. Yeah. Oh, crap. Sorry. It was important, I did that. Distributed tracing, like many things, is full of jargon. The worst one is span. So if you see this word, it is not like spam, but it is basically describing one operation within the set of others. And its most important fact, it's time. But it's contextualized like metrics with tags, like can tell you about the HTTP call or whatever it is actually representing. And it traces these things connected together, usually showing you latency relationships, but definitely causal relationships. Another jargon is the word tracer. You may see that coming up. And it's not like that when you've done all these drugs and you can no longer see straight. It's the library that actually is doing the work, like a logging library. Its job is to record this and pass context around so that you're, if you think that the call goes from here to there, that it actually did. And instrumentation is actually a shared term between tracing and metrics. Really, they have exactly the same focus, which is to bind the insight about how a library operates into things that it's reporting. In the case of tracing, it's spans, but in case of like a micrometer or something, it will be gauges or counters or whatnot. But instrumentation is the thing that hooks into your libraries to record things. So span, we've got if it's a HTTP call, it's like post and then the endpoint information, some cluster, maybe some IP addresses, and tags you might look up with. Tracing is capturing those things, it's in the tracers are going to be recording this, and I'm showing color here, highlighting that I'm not very sensitive to people with color blindness. But the gray one is one host, and then the more gray one is a different host. So the idea is that a tracer actually lives on one host. So if you're in Spring World, your Spring Boot app will have a tracer inside that Sleuth is controlling. That's going to be sending data that it can see, which is only the data from that process. And then there would be another process that you're calling maybe, and then that will have its own tracer. They're independent, so they're not sharing like a cluster between them or anything. What happens is that when you make a call from one host to another, it adds things like, if it's HTTP, we'll add headers saying what trace ID I'm in, and those will be passed to your downstream. So if you see here, for example, the root span, no parent, span ID is star. Makes a call in the same process. You would just pass the IDs. I'm using maybe thread locals or something. But if it goes across, it's going to pass the exact same IDs, but it might be over headers. The IDs are the important things. These are the things that allow you to link the calls relationship, just in case you may have 1,000 things happening at the same time, and the timestamps won't help you there. The actual data, the important parts, like the things that tell you what HTTP request it was, that's sent out of band asynchronously. So this manages the overhead. While your request is going in the critical path, only the IDs are carried. The actual big JSON stuff, they're sent asynchronously. That's how it works. And so if you're turning it on, you're turning on a utility library, the tracer. If you're using Spring Boot, you're usually having Spring Cloud Sleuth do this for you. You may not even know what's happening. That instrumentation, the framework-specific code, you either configuring it or something like Sleuth is configuring it for you. And then that, at the end of the day, is pointed somewhere to throw this stuff. And some people would just throw it in their logs, but most of the time you would send it to a tracing system, Zipkin being one of those. This is a screenshot of our lovely evolving new UI called Lens. And this is a real trace. How many here have ever used a SAS called Typeform to complete forms? Well, you should support your local businesses. This is a Barcelona company. So anyway, this is actually a live trace I got from someone today in Barcelona. This is explaining a request into their service platform. They have API proxy, and you can see the whole request took 50.5 milliseconds, hitting 3 services with a call depth max of 6, with 10 operations happening. And you can see this is a mini map, actually. Maybe not needed in a trace this small, but if you have something that's hitting like 70 services, you might need a mini map to like get to the right spot. In this case, I asked him, like, can you show me like a trace that has an error in it that would be easier to explain? So in this case, the red means error at the bottom. So somehow the call to get teams of mine errored. But if you know how to read this, and you know red means error, I know that I can't blame the queries because they all succeeded. So something else caused the failure, maybe some code, maybe a no pointer exception after the database queries return. If you know how to read a trace, you can easily contextualize things. And this is not like a class on how to use tracing. I'm just trying to look at one real life thing to show. Zipkin can be deployed as easily as a single file, even though we don't recommend people just using our in-memory option. We often have people do things that we explicitly say don't. Zipkin happens to be a Spring Boot application, and so you can start it quite simply. But the focus of this talk wasn't really like that. I did need to do some introductions here, and spent 15 minutes doing that. But here's the meat of it. What does a typical site look like? Okay, so it's nice to see images and things, but what does it mean to people? And when I talk about a site, what I mean is like a production deployment, specifically what would make it a Zipkin site. It means that there's some part of this ecosystem that they rely on, as some parts that we as a community produce. Life is dirty. It's not like you use only one thing. Like I have this one date library and I need nothing else. Because obviously you need to put it inside of a server, you need to deploy the server. There's many things that we use to make our things work. So Zipkin lives among these things. And by site owner, what I mean is that even though people have many jobs, there's usually someone who is actually more interested in something like tracing, or maybe they're tasked to do it. So by site owner, I mean like that person who's responsible. And specifically the ones who tend to publish information back to the community are pretty involved in the community. So that means that they're actually contributing back in some way, even if it's just knowledge about what's going on. So if we think about this, one of the things about this presentation, I was taking information from our wiki. So we have a wiki called Sites, and I can give you the link. I think it's in the slide deck. But we just rolled the dice and said, okay, what if we ask people to give us information? Would they actually do it? And so here's some questions that people did answer about like, what is their company doing, and like how do they set up their kit? Like what type of things are important to them? Like what type of data are they actually using? Like, because sometimes you capture a lot of information, but you don't read any of it. So what is the actual important stuff from what's just being collected? And some statistics about, like, you know, what does it cost them? So let's think about some things that happen within systems. Like if you're collecting, if you're like running a logging system, you'll need to know how much data you're going to be able to afford to keep and for how long, and what are your rules around that. Similar things happen in tracing, although usually the data retention is quite short, maybe 7 days. The things that are very, very different from site to site are like how people name their services. If we go back to like a thing like this, like these names, right? You can name things anything. Like when I worked at Twitter, they were birds, and like, you know, obviously what happens in companies is like they get big, and then eventually some SVP says, okay, no more silly names, you must name the thing, and now you have to rename the things. And so like service naming is not like a problem in tracing, but it becomes more of a problem if you don't have good service names. So like one thing that's very funny is that you kind of inherit the problems of your normal architecture when you start plotting them on graphs and such. What type of site-specific tags? So like if I'm running McDonald's, maybe like Big Macs per second is actually a pretty important fact for me. But like maybe it's also important if I'm not working at McDonald's. Actually that's really contextual, right? So actually Zip can allow you to make sure that it indexes. We have a function called autocomplete tags. So you can train it to capture Big Macs if you want. But at any rate, like there's another thing that's very interesting about sites is that everybody's in a different place. Like, are you just getting started? Are you in like maintenance mode? And our whole point about capturing site information is to allow people like yourselves, if someone is not, it sounds like actually a lot of people are using tracing already. But anyway, wherever you are in the path, there's probably someone who's not where you're at yet, or who's a bit farther, and sharing knowledge is really helpful. Anyway, why bother? So Ascend is like a financial services company. They, they said like, what was their use? Like, what is their story that they say about why they're doing what they're doing? And it's interesting what words people choose. So in their case, they're in one of these like digital transformation things. Like, do people say digital transformation here in Spain also? I think I hear it everywhere. But like, yeah, refactoring everything. And so can you find out whether your service is performing worse now? Because it doesn't always perform better, does it? So you can look at individual service calls to see whether it's actually impacting in the right direction or not. And also this idea of like non-conformance service communications. That's very like financial servicey type of word, right? But what that means is that is your application actually making connections that shouldn't be making? So if, for example, you have someone walking around and with a mesh-shaped hammer and like smacking mesh on things and saying like the mesh is doing everything, and then you actually look at your traffic and it's not using the mesh, it's just going wherever it feels like. This tracing can help you find that, right? Because you can actually see the network connections that it's making, and you would be able to tell whether or not your application is in fact using the mesh at all. So there's basically deviation from the design was one of the important things because they're going through that. Hotels.com was like, they're looking for the low-hanging fruit. Looking at, that's more like a service level triage. Like, so if you're looking to find out where your low-hanging fruit are. So if you're running anything that's booking related and you're making a customer wait for all of the things to happen, tracing is awesome for this because a lot of your downstreams can be quite slow. And so pipelining those can be very easy. It's sometimes extremely difficult especially with async libraries that we're using. We may not know if it may look really reactive and everything, but it may still end up being going on sequentially. And so it's very important to actually look at a trace to see if in fact your requests are doing what you think they're doing, or if they look like in a trace, we talk about like a steric pattern. Like you can just literally see requests going like this. And when you see requests going like this, they're not going in parallel. They're actually going very serial. And so it becomes easier to see these things. Yeah, Netflix, they're actually hitting two things. And basically, if you say it backwards, it's DevOps. So operational visibility and developer productivity. And concretely speaking, in Netflix, they're using a lot more Spring Boot. They have a lot of older applications also. If they're both in the same trace, it's a lot easier for people to have insight about the actual architecture versus just the fraction that's new and just the fraction that's old. So it's helpful to get insight over the whole thing that's going on. The infrastructure on the tracing backend, basically, if you boil it down to a couple things, in an ideal application environment, your skill sets match your architecture. It's less ideal when they don't. Tracing is no different than that. So if you create a whole bunch of architecture and no one knows how to run it or develop against it, then it's not a happy place. I've definitely worked at places where a team kind of left the building, and then everybody's like, ugh, this stuff, and then they just rewrite it, right? And so the same sorts of stuff. If you have anything that the people don't feel committed to, they call it legacy. You don't want to be like the legacy thing, although you do, actually, because that's the thing making money usually. But anyway, rambling aside, sites have different requirements. You want to optimize towards what your skills are. So in this case, if someone has more experience in Elasticsearch, they're probably going to use Elasticsearch to store their traces. If they're in a SaaS, they're going to use Google Cloud, if they're in Google Cloud, to store their stuff. And so that brings to the point, well, does that mean Zipkin Server is actually in use all the time? No, actually, we have a lot of sites that don't use Zipkin Server because they are using a SaaS. So for example, if you're using Spring Cloud Sleuth today, you can actually configure that directly with the GCP plugin to send directly to Stackdriver trace with no server infrastructure at all. It can be related to APM integration. A lot of APM products will accept the Zipkin format, whether they admit it or not. Usually you can find this out by talking to other customers. And then you have hybrids where people, for example, are storing data for long-term analysis, and then so for example, in Netflix, I think and also Expedia, they store traces in like S3 for long-term Parquet-like things, but the normal trace data is stored for a much shorter period of time, like 3 days. So that means that it's messy. It means that there are going to be some sites that will be using Zipkin. There will be things that are using clones of Zipkin, and it's sort of it depends. I think one of the more interesting sites, Yelp, is this thing called like a fire hose collectors. So they want to keep 100% data for like customer service requests and things like that. And so they have architecture where they basically store all the data, but local to an Amazon availability zone. So they have like a Cassandra cluster per availability zone, and they shoot 100% data there at the same time that they're shooting like 0.01% to a normal server. And if someone is having a question within that buffer of time, maybe it's an hour, then they can always get a trace. Whereas usually in distributed tracing, we have this thing called sampling, where you're not always taking a complete trace of the request. So there's some interesting patterns that people use. I would call that one a hybrid one, where they're sending to 2 different locations at the same time. And when you're using tracing, not everybody's using the same libraries. So for example, if you're using something like Istio, I didn't see like sparkles. What? You guys aren't working. Anyway, that's like Envoy is written in C++, right? So it's probably not going to use like Sleuth. I mean, no offense, Sleuth, but it's like not C++. So they're going to be using like direct libraries in some cases, or the application frameworks are going to be written different ways. So these headers and things, we have specifications for how these formats are written so that other parties can participate. I mean, if you have microservices but everybody has the same library, well, I mean, that's cool. That's very convenient, but the world's not always convenient. You have different services using different things, and surprisingly enough, in-house tools happen a lot. People may be like scrubbing proxy logs and schlepping that back into tracing and stuff like that. So it happens more often than you think. So. One, I don't know if it's called a case study, but here's an interesting one that people normally don't talk about when they talk about the projects they work on. Here's a project that stopped using Zipkin. So hotels.com originally started, actually, in fact, Expedia originally started with Zipkin as well. They're actually, Expedia, the company has made an interesting product called Haystack, which is kind of like a pretty evolved tool that includes things like alerting, which is pretty neat. So hotels.com started with a Zipkin backend. And so they're using apps like Spring Cloud Sleuth and stuff like that. And they want to actually send data to a different tracing system because the corporate has this like bigger infrastructure called Haystack. And so what they've done is they actually they don't bother with rewriting their apps to like send arbitrarily into a different format. They have this tool called Pitchfork, which is also a Spring Boot app, I think, and that basically just proxies the data out to the other system because the data formats are usually kind of similar, so it's not a big deal. But when their developers are doing work, because it's a lot easier to deploy Zipkin than it is Haystack. Haystack is, they have things like Terraform and stuff to like spin up the things. But if you would have that compared with like Java minus jar, maybe in some cases you just Java minus jar. And so their developers, when they're troubleshooting things, they just spin up a local Zipkin on the workstation, and then they can figure out what their app's doing, and they don't have to think about the fact that at production they're using a different tracing backend. So that's kind of helpful. And so there's a different site that didn't initially use Zipkin, and I'm talking about that. I'll give you the link later. I have it in my notes. But Netflix, I would say like in 2011, 2012, a lot of consumer like SaaS companies were making their own tracing systems. Twitter was kind of unique because they open sourced theirs first. But that doesn't mean that things didn't happen, you just didn't see it. So Netflix had their own tracing system exactly the same time as a lot of companies were doing them. And so they had, you see this word Dapper coming around, it's just a general design. And so a lot of the Java architecture they were using was using a different library. And then their architecture started shifting towards Spring Boot. And so what they have done is a couple things. One, they retrofitted their old libraries to just migrate things a little bit to use the same header format as Zipkin uses, which is called B3. And B3 stands for Big Brother Bird, which is some nice trivia if you didn't know that. And that's because the design before Zipkin was actually a system called Big Brother Bird. And that was when Twitter made all services with bird names. Now what they have at Netflix is actually a Flink pipeline. So Flink is sort of like Spark. Flink people might not appreciate me describing it like that. But anyway, it's a streaming architecture. And the idea is that they buffer the data to a certain point where they realize that it's kind of complete or not. Like maybe I have all of the data from all the hosts, and then they shoot it to analysis, and then they also ship it to various storage things. So in their pipeline, they have data coming from the old systems. They convert it to Zipkin's format, and then the boot apps are already sending in that. And then as it ends up in Elasticsearch and other things, it's all in the same format. And so it's a lot easier for them to do aggregations and fancy things with it. We have a site that has never used our server, but are quite prolific contributors. So Interstellar is a space communications infrastructure firm in Tokyo. So it's a startup that does things like rent satellites, I think, and or antennas specifically. And so they actually use a myriad of different libraries depending on what was easiest or whatever they decided. You'll notice that in different language, like if you're using a certain programming language, people will tend to certain libraries, and there's a lot of camps in the world, right? So the main thing is if they can get everything into the same data formats, everything's fine. And they actually were the ones that work most on our Google Stackdriver integration. And so that means that they actually have no server footprint whatsoever, even though all their instrumentation libraries are using Zipkin format. And we have another site that's interesting because it has done not much notable. I think it's also nice to talk about the things that are not fancy. So Metadata is an entirely Amazon architecture. They use the stock Amazon Zipkin image. So they use SQS to send the data around. And because they don't have a lot of traffic, they're fine to actually collect 100% traces. So one thing that's funny is that like if you're running something like a mobile app, then you can't really collect the data for 100% of all of your communication. If you're doing anything like IoT, that's not really going to work either. But if you're doing things like forms filled out for a company or like high-value transactions, you can keep 100% of that. So in their case, they choose to collect. I think they even keep it for like a month retention because there's no reason for them not to. So there's no right rule about how much data that you keep. It's more about how much can you afford to keep, and when's your storage going to fall over. They did do something pretty interesting. They have because they know that the data is in their case going to Elasticsearch, although that's not the only storage option. They kind of found a way to do some performance analysis and try to figure out how many people are calling deprecated APIs. So once you get these causal information, that's the cool stuff, where you can find out like, okay, what patterns of communication are not fun. So I would say they're stock, but they also add something called SLAP, which is Service Level Agreement Policy. I think they just wanted to call it SLAP. But basically, they made a reporting system that would be slapping people if they messed up someone else's service level agreement or their services were calling deprecated services. And so they get the slap report sent, and it really helped them drive behavior in the company because name and shame is just a very effective tool. And you can't see, it's kind of like fuzzy here, but basically it's not a very fancy UI. But it will show you this is like logs, how long you were when you went out of compliance, and then you can click on each trace that went out of compliance. And so they have some services that are very green and some that are very red, and so people get motivated by those things. So besides architecture, like what might be different? Like I kind of hinted at this and kind of talked about it, but data collection policy is very different between sites. And I wouldn't say it's different always, meaning that like if people start using the data, they start figuring out what is important to talk about. So for example, in Typeform, the one that's here, right? All their apps, they always produce a request ID. So regardless of whether you're tracing or not, they're using like the kind of standard pattern of creating an incoming request ID. And so they're always doing correlation with that. That's the most important thing for them, is to be able to have their users look up things based on request ID. When InfoStellar are working, like as opposed to Big Macs, they're mostly concerned with antennas. So they have auto-completion needs that would be related to antennas and satellites, because those are actually what's valuable to the company. Many companies have had eras of microservices or digital transformations, and each one leaves like a stain in your service catalog. So one of the funny things I like to see is like when these happen, and you can see like, okay, everyone decided that the service is called instance today, and then like 2 years later it's like, no, it's service. And so now you have both. So in their case, they have some things that are indexed, and they've trained everyone to look for the word instance instead of service. And so for them, they want, like the UIs usually say the word service, and they're like, no, please change it to the word instance, because it took us like many years to tell people to use this name. So we have to use this name. And phase instead of environment. So like it's vocab, and it sounds silly, but it's important because infrastructure teams spend a lot of time on this, and it can be frustrating if all of that happens, and then you have no means to present those words back to the people using the system. So, and then a funny thing that happens with public services like Expedia or Netflix is secret scrubbing. So if you have things in your traces, usually you can accidentally leak data. Maybe you think you're like logging a prepared statement with question marks, but there were no question marks, and whoops. So there are, data collection policy, depending on whether it's happening inside of the app, like whether you're adding a handler to scrub out some sort of data, or whether you're doing that in like a RabbitMQ listener or whatever. Oftentimes there are secrets to scrub. I remember asking folks at Netflix, because now they're basically a movie production company. They're no longer a streaming company. And I said, do you scrub, or do you have a secret scrubber? And Nara responded to me. He said, no, we don't. We have 3. There's some story about like how some movie star like got their data about their private phone number or whatever. I don't remember, something like that. And so like all of a sudden like the answer is, okay, 3 secret scrubbers. The other thing is, I hit this before, but like data retention is conditional. So Netflix used something called fit. So basically they have a feature flag type of thing to say if an experiment is going on. And believe me, you have a lot of experiments going on if you're ever using Netflix. And so they will, during certain experiments, they'll collect 100% of traffic for those type of things into traces. And so based on headers, they decide whether or not to do that. So if you're using something like Sleuth, then you can see that there's ways to change your sampling policy based on HTTP requests. And one of the reasons could be that you want to get more traces because you have something important happening. And like there's some sites like SoundCloud that just can't rationalize storing that much data because they have so much traffic. And so SoundCloud's sample rate is quote unquote very low and maximum 7 days retention. SoundCloud is actually a very interesting site doc to look at because they had an interesting way to deal with like this service naming problem. Basically they went and they looked at the IPs from the Kubernetes pods and then rewrote the service names because the developers were always using junk. And so they would just say, forget it, we can't trust any of this. We're going to carte blanche rewrite all the service names. And so now their service graphs are fun. And now if your service names are not correct, like what's a problem? What does that happen? It looks like you're calling 2 different services when you're actually calling the same one. It's just that this web controller named it this, and this web controller named it that. And so someone who's looking from an architecture point of view thinks that it's actually round-robining between different services, but so it can get messy. So one of the most common things in all of these sites is you get to a certain point where you're collecting the data and you're like, huh, that doesn't look right. And it's something that you have to, you end up with data policy. And then, like all technology, adoption is never really 100% when you get to a complex company. And so that's one of the things that's interesting. Sometimes one team is responsible for 90% of the traffic. And so it can sound really neat that you have like 90% of requests traced, but it's only like one team out of like 100. So the numbers alone don't tell the full story. So anyway, I'm going to leave some minutes for questions. This is the last slide with content on it. And you can come back to this. I'll post the slides. But there's some archetypes of how people get started. And basically, these are the ones I've noticed. There's the greenfield. Greenfield is always the easiest because you just roll out things and you do what you want, right? That's why people want to work in greenfield. And if you're working in brownfield, existing environments, most people will start with a single service, just like almost any technology. And so even one of the things hotels.com said is even if it's not actually that distributed, you're only like one service and it's making one call to another service the same team uses, you still get insight about like what's going on, and that can be virulent with regards to other people being interested in what's happening. It also helps you when you look at your service diagram, because you can actually see your service diagram grow based on adoption, and that can help with manager types with pointy ears and things. Proxy is another pattern. If you have anything in proxy in nature, instrumenting that can be helpful. So like in Typeform, they started everything in their proxy because that was the easiest way to get some data. And then the other thing is just like slapping it onto a framework rollout. So if you have like a Spring Boot project, then just having tracing built into that is easy because you already have it, like you just put Sleuth in there. And so it's an easy answer. So anyway, let's wrap up. Here's the link. You can start with questions now for the time between me and beers. We've got some other things. So the sites, you can actually look in the history and see who's literally editing those things. You can add a comment to them. People will answer you. So like this is not like static. This is a community. So do take this information and think of this as people like yourselves, and ideally some of you will even post your own site docs. If you're interested in this stuff, we have a Gitter channel, and some of you have probably already found it. And if you like what we're doing, add to our star collection. So, questions? So the canonical Zipkin Java, is that what you're asking? The canonical Zipkin Java library is Brave. And for Spring Boot, it's actually Sleuth that has a lot of the instrumentation integration. And I think Martin, who's right here, can tell you that he's spent probably half of each period of time in async. So it's a pretty important thing, and maybe not always fun. But there's definitely work there. The most important thing in async comes in a couple ways. One is when you have like a chain of events, like how the current trace that's happening gets moved between each of these phases. That's called context propagation, and there's patterns for that are in the libraries there. And then the other thing is like knowing the difference between creating the call and invoking it. So like this assembly time and runtime of async. And I wouldn't say that anything's perfect. Async is where most of the bugs lie. But yeah, a lot of libraries will have async support at this point.
Do you have any insights about distributed tracing costs in terms of performance? Because we are using, as you see, Spring Boot 2 with Spring Cloud Sleuth with a Brave implementation. And we've made a test days ago and found that almost 30% of performance is lost when using distributed tracing with a lot of requests. Do you have any insights of the normal performance penalization of using distributed tracing?
Okay, so I think the question is more, when you say cost, like I was actually going to, I started looking up this, which is like, we have some people who are talking about how many currency units, yen in this case, they're spending on tracing. But you're talking about costs as far as overhead, I think, right? Yeah. So the highest overhead is in async tracing. Synchronous applications are much cheaper to trace. There's less work involved in that, and it's a moving target. So what I would say is that when people find a specific source of overhead that's higher, the things that usually affect that are the amount of things that are like propagated. Like there's a way to add headers and then like called like baggage in Sleuth terms. That tends to slow things down. Synchronizing logs and things like that, all these features have a cost to them. And so I would say that there's always progress happening here. Actually, I wouldn't say it's always progress. Here's why. If you move from one type of library to the next, sometimes you think that is going to be performance increasing, but it maybe changes some patterns, and it's actually worse for a little while. So I think everybody wants to have an answer like it's 3%, but that never is an answer. What you've done is actually important, which is to measure.
It was a reactive application, in fact.
That?
It was a reactive application with Parry Reactor, in fact.
Yeah, that's the worst performing under tracing right now. And the good news about that is that that means it's probably going to improve. But there are definitely some scenarios about that are inherently non-performant. So when you look at tracing, you should look at the before and after, and it can be tricky to do that, to be honest. One of the things that you can do is nice with something like Sleuth is you can, because it's Spring Boot, you can do something .enabled and set it to false, and then do your before and after, because that's probably how you came up with whatever the 30% is. And so when you report an issue, if it can be diagnosed to where it's a source of overhead, then that can help find it. But I think the plain truth is that reactive is the highest overhead thing to trace at the moment. Sorry. Other questions? I would tell you some interesting things about overhead real quick. We actually are working on, we have now this thing, how many people have heard of protocol buffers? A lot of people have heard of it. When you're creating data for any system and you're sending it out of process, like whatever's being created, even if it's async, has some side effects like extra garbage collection, other things like that are going on. We have we have a release happening now in Zipkin, which is not finished being voted on, but 2.14. We have some pretty fun things. One is we have this thing called storage throttling, which means that everyone is complaining sometimes about like Elasticsearch falling over, and it's like sending like my queue is too full and dying, and then people, all their data gets dropped. And so we're using a really fun library called Netflix concurrency limits, which watches your exception patterns, and then it will back off for you. And it's kind of neat. That's a tool. So we're using it in the server, and we have a lot of cool efficiency improvements if you happen to use the protobuf encoding. So that's going to be probably a little bit of time to get that into a Sleuth dot release, because this hasn't even been released yet. But if you produce JSON, the good thing is that you can read those requests, but you don't always have to read them yourself. So if performance is important, switching to protobuf format, even today before this release, will reduce the amount of garbage created and the amount of CPU your process uses. It may not have anything to do with what you're doing, but basically thinking about what's going on behind the scenes can help reduce this. Anyway, I'll leave you with the links. I'll put that slide back up. And thanks for spending time. I'll be joining many of you for beers next.